Hello, hello. Today we're going to start my new equipment. See this? Cool, right? So wireless headsets. I just bought it just for you guys. Don't believe anything you hear out there saying that I bought this for gaming or for watching TV. That's not true. Okay? I will watch TV and play games with it, but I bought it only for you and for these videos. Let's begin with analyze. So we're still digging into analyze, and we have a bunch of things to see. Oh, let's go so much. No, we're here. So we're in Anova. We looked at one-way Anova. If you guys remember, the one-way Anova is the one that I have an attribute, right, a categorical variable as x, and I have a y variable as a continuous, right? And I'm taking a look at, let's say, what's the difference of shift number into quality or performance, what is the difference between the productivity of two different people, what is the difference between any groups, right, that you're dividing it by, right? But I have still one categorical variable that I have multiple classifications within it, but just one thing that I'm looking at. The two-way ANOVA is going to take a look at two things at the same time. So imagine that I'm looking at shift number and product type at the same time. So there are two different things that I'm looking at to see the impact of those two things at the same time. Okay? So in this case, it's called a two-way ANOVA. So I have two categorical variables and one continuous. Okay? And I can test three different things. I can test the impact of each one of them and the interaction, and we're going to see what that is. So let's take a look at this one. Here I have the two-way ANOVA example. I have shift 1, shift 2, shift 3 data. I have product 1 and product 2. So I produce those two products in each shift. These are the defects per 10,000 units produced. My hypothesis, my null hypothesis is all shifts produce the same defects here. My null hypothesis for products is all products have the same level of defects, right? This is the table. You can see that's a little bit more complicated than the one that we saw before, but it's the same structure. But now I have three things that I'm testing at the same time. So I'm testing the sample, the column, and the interaction. But the rule is the same. I just need to take a look at the p-value here. And let's say we're using 95 confidence level, so the p-value would be 0.05. But let's remember that rule that you can need to only remember for this class and for green belt exam. You have to divide the p-value by the number of things that you're testing at the same time. In this case, we have three p-values, so we're testing three things at the same time. So take the 0.05, slash it, and divide it by 3. Okay? So I'm dividing this by 3, and my criteria here is the p-value have to be lower than 0.17. Any of those values lower than 0.17? No, they're not. Since they're higher than my threshold, I cannot reject the null hypothesis. Okay? I can only reject if they are higher than. And I'm looking at sample, columns, and interact. So, easy thing to do, start with columns. What our columns are? Shifts. Shift 1, shift 2, shift 3. These are columns. So here is when I'm going to take a look at the p-value for a significant impact of shift into quality. Sample will be the rows. So whenever we talk about sample, this is exactly the one that Excel gives it to you. And that's a two-factor with replication. That's the name that Excel gives to us. We have product 1 and product 2, and we'll call that a sample. Okay? So if there's something going on, the p-value will be significant, and I will explain interaction as we go forward. So this is just another thing that you can do, build it into the confidence interval. Okay, so here we have the means of each one of these samples. So going back here, what we have now is a multiple number of subsamples, right? When we have 3 columns, I had 3 samples. Now I have 3 columns and 2 products. So how many samples do I have? Yes, I have 6 samples. That's exactly the number that you said, right? So you can see that they're divided here, right? I have shift 1, product 1 sample, shift 2, product 1 sample, shift 3, product 1 sample, right? So 3 samples here, 3 samples here, total 6 different samples, right? And imagine that I calculate the mean of each one of them. Basically, that's what you're doing. You're comparing the means of these different samples. First looking at columns, then looking at products, and then looking at all of them together would be the interaction effect going on. Okay? So, sorry about that. You guys can see my emails coming in. So we have here the mean sorry, of each one of them. So each one of the 6 samples. And you can see then which one has the higher mean, for example, right? You have shift 1, product 1, shift 2, product 2, shift 3, product 1, and so forth, so on. You have the grand mean of shifts, you have the grand means of products, right? So we're comparing each one of them pairwise to do the two-way ANOVA. And if you take those means and plug into a line chart, that's what you're going to get. So each line is a product, so I have product 1 and product 2. Each column is a shift, so I have shift 1, shift 2, and shift 3. When we plug these means, we get this chart. And as you can see, they are horizontal, right? Why are they horizontal lines? Well, because there is no difference between product 1 and product 2. So if there is no difference, the means have to be very close together and even overlap each other, like cross each other like this. If the means were very different, how would the chart be different? Well, if product 1 is different than product 2, the means are different, then you have to see those lines farther away, right? Because there's 2 lines. So if they're close together and overlapping like this, I cannot say that they're different. But if one is up here, one is down here, then they're probably different, right? So going back to our chart here, if the lines are far away, I can understand that they're different. What will happen if the shifts are different? For example, if shift 3 is a lot worse, has a lot more defects than shift 1 and 2. Well, what you would see is that these lines will have to split, right? So you can't be straight like it is now. They have to go up or they have to go down somewhere along the way, right? Because one of the shifts will have a higher number or a lower number of defects. We'll talk about defects in any given time, right? Does that make sense? So this is what you have, the chart, when you have no difference between shifts and no difference between products, okay? So I'll record the other examples in other videos.